As a short digression, I wanted to say something about locally closed sets and constructible sets. This is not really needed for the rest of the lecture, but it's a kind of nice thing to look at, and one can show a cool result about morphisms of pre-varieties. So in the lecture, we have seen the concept of open and of closed sub-pre-varieties of a given pre-variety. And sometimes it can be useful to mix these. This is the following definition, which can be presented in a very big generality, so that X be topological space, and the subset S in X is called locally closed if it is the intersection of an open set U and a closed set C inside X. And it is called constructible if it is a finite union of such locally closed sets. Before we do a remark, one further remark is that locally closed generalizes both open and closed sets. Because if you have, for example, U open, then you can take C, the closed set, to be everything, all of X, and then we see that U is locally closed. And similarly, if you swap the roles, then also any closed set is locally closed. So this is kind of a category of subsets which contains both the open sets and the closed sets. And then we can see some examples. So inside X equals A2, for example, we have that the set 0 cross A1 minus 0 is locally closed. So this is essentially in this picture, like everything is in where one coordinate is 0, but then you exclude one of the points. So it's kind of the complement of this blue set. And indeed, we can write it as the intersection of an open set, namely the open set where the second coordinate is non-zero, and a closed set, namely the set where the first coordinate is 0. So this is a locally closed set. And then its complement here, Z, turns out you can write it as a finite union of locally closed sets, namely as the union of this open set here and this closed set here, as we constructed it in the lecture. And so this is clearly constructible as a finite union of locally closed sets, but it's not locally closed itself. That's something you check. And so we have seen examples of these two concepts. And the first thing is that you don't just have open subvarieties, open sub-pre-varieties or closed sub-pre-varieties, but in fact, if you have S, a locally closed set, so for example, S is given by U intersected C, U open C closed inside a pre-variety X, then there's two possible ways to give this the structure of a pre-variety, because we can see it as an open sub-pre-variety of C, or we can see it as a closed sub-pre-variety of the set U. So you can see these are two different possible structures. And then the exercise would be to convince yourself that these two structures of pre-variety are isomorphic by the identity. So in other words, it defines the same structure sheaf on S. So we could also talk about locally closed subvarieties, locally closed sub-pre-varieties of a given pre-variety. So that's one observation. And then the other why these kind of constructible sets are really nice is that in the main lecture we saw that the image of an open or closed set under a morphism of pre-varieties is not necessarily open or closed. So in particular, we had a map from A2 to A2, which had this as its image. And this is neither open nor closed. It's not even locally closed. But in fact, there's a big theorem, which we don't discuss in the lecture, but which I want to show once, is it's called Chevallier's theorem. And it says that if you have a morphism F of pre-varieties, and you have S inside its domain, a constructible set, then the image of this constructible set is still constructible. In particular, for this map that we had in the lecture, this was exactly this map. We saw that if you take the image of all of A2, then you get this set Z, and indeed this was constructible. So in particular, we see here, take S to be all of X, then we see that the image of any morphisms of pre-varieties is a constructible set. So in principle, it can be described by finitely many either equations or inequalities in the coordinates there. Okay, that's everything I want to say about these kind of locally closed sets and constructible sets.